Hello students, let us understand discriminant analysis. Discriminant analysis means this related to classification. So let us consider example. Consider student performance data. Business analytics students performance data I am having. I need to classify this data into two groups. Pass and fail, that can be the classification, or another way, the grouping based on their performance, based on the grade. So group of students who secured outstanding, group of students who secured grade A, group of students who secured grade B. Like this is called as classification. To perform classification, the discriminant analysis is used. We'll understand what is discriminant analysis, example, and how to carry out discriminant analysis in R in the next few minutes. So discriminant analysis is a technique for analyzing data when the criteria or the dependent variable is the categorical variable. As I had given the example, the grade, the target variable is the categorical, that is it is related to classification problem, and other variables are interval, numeric in nature. It's the technique to discriminate between two groups, as I said, pass or fail, or it can be for multiple groups. So types of discriminant analysis: linear discriminant analysis, where we are having only two categories, only two groups, whereas multiple discriminant analysis indicates we are having categories, multiple groups, more categories, more groups of values, observations there in the data set. Now, just showing graphical representation of linear discriminant analysis. So, you can make understand here, set of observation having red color, set of observation blue color. The line here, this line clearly separating two groups. So, this is linear discriminant analysis, where if I do the line in this way, then it is the quadratic discriminant analysis. This line can be represented using linear equation, and here the line is represented using quadratic equation. We are having two classes of values. Let's take one more example, numeric example I'll take. Consider a purchase data compared to person's age. So the age and the purchase. 0 indicates there is a purchase. 1 indicates while 1 represents someone who did the purchase. 0 indicates not done the purchase. So age is plotted along the x-axis and the purchase along the y-axis. So 18, 0, 19, 0, 20, 0. That means 0 indicates the item is not purchased. 1 indicates the item is purchased. Say for example 22 here. 1 means item is purchased. So if they try to understand the data first, the plot here, 0 the age, observations having the age, not purchased, observations having the age, purchased. The discriminant line can be like this. See, the potential customers who did the purchase is like this. Potential customers who did not purchase is like this. The discriminant line can be drawn in this way. Here, the discriminant analysis fits a linear regression to this data. So, some amount age who are belongs to, the regression to this data through categorical variable was numerical here. That is 0 or 1. See, if I consider age 40 at this point, if you observe the who are falling below 40, the less number of purchase, who are, you can just observe this data. observe this data. The lesser than 40, the purchase is very few, and the more than 40, the purchase is more. So considering this, see, as the age indicates, the purchase is more here. As the age lesser than 40, the purchase is 0. So two classes. So this line can be drawn like this. There are some exceptions. Always it is there. They are residuals, they are errors. So the discriminant line here we have drawn in the form of regression line. So at the point, at the age 40, so if you consider at this point, that is 0.05, here the values, these are the who are having age more than 40 have purchased, who are having age less than 40 have not purchased. So these are all residuals, these are all errors. So then discriminant analysis 0.05 is treated as cut, 0.5 is treated as cutoff. For a single predictor variable, this score where is the regression line is equal to 0.5. Any data points left of the line are predicted to be 0, while those are right of the line predicted as 1. So 0.5 is treated as cutoff score. For this data, any potential customer below the age 40-41 predicted to be not to buy, while anyone above the age predicted to be buy. Now, one more example I'll take. So there are two groups. So group A would adopt, group B would not adopt. So based on three parameters. So quality, accessibility, price. These are the indicators. These are the independent values. They predict whether the person adopt or not adopt. So target value we are having to adopt and not adopt, that is group A and group B, and the quality values are like this. So if you try to plot, then see each observation can be plotted here. There can be one misclassification. This is always possible in the classifier, that there can be some misclassifier. If the discriminant line is considered in this way, then there is a misclassification. So we are considering for the quality attribute, the value somewhere 4 or 5 is taken as the discriminant line. Here we are taking the value 4, 6. So which are having higher the value, then it is adopt, lesser value not adopt. Still there can be some misclassification. So this is the discriminant line, cutoff line, making two groups of person. So the dots here indicates observation. So it can be the discriminant analysis, the equation can be represented like this. Same as your regression, the y is equal to mx plus c, the equation we can define discriminant function in this way. The discriminant value is equal to the constant with the three variables x1, x2, x3. That is, consider you are having these three characters or these three independent variables, then the constant, same as your y is equal to ms, similarly here this is equal to the constant into the variable. This depends on if the data is having three independent variable, then discriminant function is equal to constant with the independent variable. If you have more than one or two independent variable, those variables will come in your discriminant function. The analysis model, it's like a multiple regression model. So we can give a final equation in this way, D, the discriminant value analysis score is equal to discriminant coefficient or the weight at each predictor value with the constants. So same as your multiple regression model. The coefficients or vector weight B are estimated so that groups differ as much as possible on the values of the discriminant function. So mainly here it is the classification model where different groups, so difference among the groups are analyzed, presented with the help of these weights. Now, let's consider R code, performing discriminant analysis in R. So, I am making use of iris data set. You're all aware of iris data set. So, there are 4 independent variables: sepal length, sepal width, petal width, and the target predictor is the type of the flower. That is what the categorical variable. The process is like this. We are splitting the data. So the sample function, actually just recall the iris data set. So this is the data set. This is the target variable. So data set having 150 observation. Let us do sampling. So the process is like this. Here the step first, we are applying sample function. The sample function is applied 1 to 150 observation. So from this 100 observation is treated as training data. So actually data is split into training data and test data. So the 100 observations are 100 indexes are fetched, stored in the index variable. The iris of index, so that is the training data, and remaining 50 are treated as test data. Then applying LDA, that is linear discriminant analysis modeling using the function LDA function. So how to give this LDA function? The target variable, this is the formula, target variable dot indicates all the independent variable. We are performing this on the training data, and this model is used for predicting the value. I'll show you in R. See, let us split the data first. Training data, test data. You can check what is there in 100 observations there in the training data, 150 observations there in the test data. I am performing the LDA model, plot the model, and then once the model is ready, apply this model. The predict function here used, this model, LDA model, this model is there in the variable model. This model is applied on the test data and verifying. So if you observe this is the confusion matrix. So actual value and the predicted value. In the test, this is the actual value and this is the model predicted value. So you can do the comparison. So 22 are actual and predicted also 22. Versicolor 12 are actual, predicted also 12. So only one there is a misclassification. So now what it indicates? The indication is like this. Indication is that we applied LDA function on the iris data. LDA function, that is linear discriminant model for iris data, classifies the data into proper 3 groups with very less error. This is the conclusion. So please try this program. Apply LDA function for